Hello class, today we're going to talk about section 6.2, which is substitution. By the end of today's lesson, you will be able to substitute to solve systems of equations. So as we discovered in yesterday's lesson, graphing is not the most precise way to find where two lines intersect. So substitution is one of the algebraic methods that we can use to figure out the answer to systems of linear equations. This means that we are replacing one of the variables in the equation with another formula. The solutions are still ordered pairs. So, steps for solving. First, if necessary, you need to isolate a variable, get it by itself on one side of the equation. Once you have that variable isolated, you're going to plug in that formula that it's equal to into the second equation so that there is only one variable in the second equation. You are going to then solve for the variable in the second equation. Once you get that first answer, you're going to take that answer and plug it back in to find the second answer. It doesn't matter if you do x or y first, whichever is simpler based on how the problem is set up. For the simplest example, this is something that we did last year. It's going to give us just a number to plug in. So we've got 2x minus 5y is equal to 11, and it's telling us that x is equal to 8. So what that means is we're substituting this value into the place of x. So I've got 2x, and instead of x, I'm going to say 2 times 8 minus 5y is equal to 11. So then we're going to continue solving. I've got 16 minus 5y is equal to 11. Subtracting 16 from both sides, I get negative 5y is equal to negative 5. And to finish solving, we're going to divide by negative 5, giving us an answer of y is equal to 1. Now, because they already gave us the first answer, there's no plugging it back in. So you do have to write out your final answer, however, though, as 8, 1. We are still looking for that point of intersection, which means we still need that ordered pair as our answer. I'm telling you right now, on the homework and on the test, if I'm seeing that, it will be marked as wrong if you do not have this ordered pair written out like so. Go ahead and try this one on your own. Notice this time we plugged the value in for y instead of for x. And we went through and solved in a similar fashion, getting an answer of x is equal to 25. So our final ordered pair is 25, 8. If you have questions about this type of problem, please let me know when you get to class. The next type that we have is when the variable is isolated, but instead of being equal to a number, it's equal to a formula. So we've got the y by itself, but instead of just equaling 6, for example, it's equal to this whole expression right here. So we're still going to plug in the place of y so that the y goes away. But this time, instead of plugging in a number, we're plugging in a whole expression. So what this is going to look like, we've got 5x plus 3 times, and then in parentheses, we have this whole expression. And that's still equal to negative 1. So we took what y is equal to and we replaced it in the second equation. So instead of having an x and a y, now we just have x in the second equation. We can solve this by using distributive property. So we got 5x plus 12x minus 18 is equal to negative 1. Now, because I have two x's, I've got like terms, which means I can combine those into 17x minus 18 is equal to negative 1. I'm going to go ahead and add 18 to both sides, which gives me 17x is equal to 17. And when I divide both sides by 17, I end up with an answer of x is equal to 1. So now we know what x is equal to, but we still don't know what y is equal to. So we're going to take this x answer, and this is where we have to do that final steps of plugging it back in. So we're going to say now that y is equal to 4 times 1 minus 6, because now we know the value of x. So we've got y is equal to 4 minus 6, giving us an answer of y is equal to negative 2. And taking that final step to write our answer out as an ordered pair. So I've got 1, comma, negative 2. So if I were to put those two lines on the graph, they would end up running into each other at the point 1, negative 2. Go ahead and try this one on your own. So we started by plugging in that expression for y, distributing, then simplifying down to one variable, solving to get our first x answer. Then we took that and we plugged it back into the equation, giving us this green expression over here, and a final answer of y is equal to 13, giving us the final solution of 213. If you have questions about plugging in the formulas, please let me know when you get to class. Then, for this last part, the variable is not always isolated, so sometimes we have to do step 1 and get the variable by itself to start. So if we're looking at these two equations, neither of them have one variable by itself, but this second one is closer to getting a variable by itself. All I have to do is add 3x to both sides, and now I've got y is equal to negative 13 plus 3x. So now I've got a variable by itself, and I am ready to go. So I'm going to take this expression that I have and plug that in back up top in the place of y. So now I've got 4x plus 5 times negative 13 plus 3x is equal to 11. Using my distributive property, I'm going to end up with 4x minus 65 plus 15 is equal to 11. Combining my variables, I get 19x minus 65 is equal to 11. I'm then going to add 65 to both sides and end up with 19x is equal to 76. When I divide both sides by 19, I end up with an answer of x is equal to 4. So there is my first part of my answer. I'm then going to have to go back and plug in my x. So I've got y minus 3 times 4 is equal to negative 13. When I do that multiplication, I end up with y minus 12 is equal to negative 13. Adding 12 to both sides, I end up with y is equal to negative 1. So there's my second answer, giving me a final solution of 4, negative 1. So taking that extra step to get the variable by itself to start on this one. Go ahead and try this one on your own, isolating that variable and then continuing to solve the problem. So we've got to get the x by itself this time because that is a simpler problem. Getting the x by itself, we get x is equal to negative 1 minus 2y. Plugging that in and simplifying, we can solve all the way down to get to y is equal to 0. Then we're going to go ahead and plug that back into our equation, giving us the green expression over here. And solving, we end up with x is equal to negative 1. So our final solution is negative 1, 0. If you have questions about isolating the variable, please let me know when you get to class. Last thing that we have to do, this is similar, but it's going to give us a different type of answer. So we're going to take our variable and plug it in, and I end up with 2x minus, and then in parentheses we've got our 2x minus 3. Just because there's not a number there doesn't mean that we can't put it in. So that negative 1 is what is going to be distributed to the expression. Be very careful when you've got subtraction. in the second equation that you are distributing that negative to both pieces. So we got 2x minus 2x plus 3 is equal to 8. When I combine my variables, I get 2x minus 2x, which gives me no x's. So my x's are going to go ahead and cross out, leaving me with an answer of 3 is equal to 8. We all know that's not possible, so this is an example of what no solutions would look like with a substitution problem. So you end up with two answers that are not equal to each other. Go ahead and try this one on your own. This is an example of an all solutions problem. Again, after we combine, our variables cancel out, so the 0x goes away, and we get negative 12 is equal to negative 12. So that gives us all solutions because it is a true statement. If you have questions about all solutions or no solutions, please let me know when you get to class. Last part, of course, is a word problem. So they're giving us this table to show that a store sold a total of 125 car stereo systems and speakers in 1 week. The stereo systems sold for $104.95, and the speakers are $18.95. The sales totaled to $6,926.75. How many of each item were sold? So they give us this nice table to help us make our equation. So first it says that we've got a total, so that means we are adding up these two to get our third piece. So we've got the units sold plus the units sold is equal to 125. Similar situation with the second one. This is just looking at the prices. So we need to pick one of our variables to get by itself. Since both of our variables can easily be isolated, it doesn't really matter which one you do. I'm going to solve for c by subtracting t from both sides to get c is equal to 125 minus t. So I'm going to go ahead and plug that in to my equation down below and get 104.95 times 125 minus minus t, and adding on the rest of the equation. Alright, so now we need to use our distributive property, and when I do that, I get 13,118.75 minus 104.95 t plus 18.95 t is equal to 6,926.75. So then I'm going to want to go ahead and combine my variables. Oopsies. So 13,118.75 minus 86t is equal to 6,926.75. Then I'm going to go ahead and subtract the 13,1875 from both sides. Which is going to give me negative 86t is equal to negative 6,192. I'm going to go ahead and divide both of those by negative 86. And I get an answer of t is equal to 72, which means that we have 72 speakers that were sold. Now we need to go back in and solve for the stereos. It's going to be easier to plug back into the first equation. So I'm going to take that and say c plus 72 is equal to 125. And then I'm going to subtract from both sides 72, which gives me a final answer of c is equal to 53 stereos. we have a word problem. We do not need to write it as an ordered pair because we already have both of our answers labeled. If you have questions about this or anything else from the lesson, please let me know when you get to class.